Hi everyone, in today's video we will solve the program which we have on this screen now. It is from C programming and from the website cppbuzz.com. So you will in this video you will not only learn how to solve this, but you will also learn how to compile C program on Linux operating system using GCC compiler, and we will also make use of VI editor. Okay, so before moving further, let's discuss the output of this program. The output of this program is D, which I can see after pressing this button as well. So the answer is 64. The input was 332, 320, but the output is 64. I will explain you why it is 64. But before that, let's run this program on Linux operating system. And so before that, what I will do is I will copy this program from here, and I will delete all content from here. So I'm connected to my Linux virtual machine using Mobile Extra SSH client. You can also make use of this. You can also create virtual machine if you want to try this program on Linux, or if you want, you can also try some online operating system portals. So let me create a file using vi main.c. You can have any name. You can give it any name, but extension should be C. Once I've hit enter, it will create an empty file. So if I want to type or want to paste my code, I have to first change it to insert mode. You see this message after pressing I from the keyboard. And after that, I will do right click on mouse and say OK. So I have this program ready, but this program will not be compiled because the header file is missing. So let's include the header file. Header file for printf is the stdio.h, and we don't need to use any other header file. So we have this code ready. Now to go out or to come out from the VI editor, I have to press escape shift : WQ. Yeah, so I can make sure the file is created by doing dir command. After that, what I will do, I will compile this code using GCC. Syntax is GCC, then file name. But if I run this command as it is, this will generate a binary file a.out. But if I want to give some specific name, then I have to make use of -o flag, and I can give something or any whatever you want, main.out or main.exe, whatever you want, or anything would work. I'll say enter. So once I press enter, I don't see any warning, neither error, nothing. So to make sure we have this binary file created, I will again do dir, or you can also do ls-ltr. So I see this binary is generated. Now how to make sure this is binary or some other file? For that, we have file command. We can make use of file command and then pass the binary name. Once you press enter, you will see this message here. This is executable. That means it is binary, and this is 64-bit binary. Now the thing is that it is 64-bit because we compile it using 64-bit compiler. If you want to try, you can also compile it using 32-bit compiler. Let's run this. For that, we have to use -m32 flag. So -m32 we use if you want to compile this program as 32-bit, and our compiler is 64-bit. So once I run this, you see this has been compiled, and let's run it. And the output, the output is 60. Output will not change, but if you check the output of file command, you will see this is 32-bit. So I was showing you how you can compile the same program as 64-bit or 32-bit. So now, if the compiler is by default, if you are not specifying any flag, so by default the compiler will compile like following whatever bit it's supposed to have. Like, so this one, so on this operating system, the GCC 64-bit. So if I'm not specifying anything, it will generate a binary for 64-bit operating system. I can press enter, and if I check for the file, it will say 64-bit. Okay, anyways, this was something different. So if I go back, so the output is 64. You see here. Let me format it in better way. So So I'll go back to the file, edit it using vi, and after printing I will make use of slash and new line character. I will save it and then I can compile it and then run it again. If you see here, it is 64. Now let's come to the point why it is 64. This is a very interesting program. So for that you have to convert 320 into the binary format. So to convert this program, or I should say 320, let me write it here. I'll go in insert mode and let's use a comment, single line comment. So when I say 320, so if I convert 320 into binary form, if I'm converting 320 into binary form, the binary number is, I think, 101 and then 6 times 0. So basically 9 digits. So this is the binary conversion of 320. Now what happens at line number, let me enable the line number as well. So line number 7 we are initializing with 32, and after that we are declaring a character pointer. Some people call it char pointer, and then converting, typecasting into this. This is called typecasting. This is C style typecasting. So we are converting this address of this variable into character type pointer. So you remember, whenever you are converting into lower data type or higher data type, what it will happen, it will try to store this value is less number of digits, or the bits the new data type is taking. So here character takes 8 bits to store the values. So what will happen here is, we have this value here. So when we typecast into char pointer, it will just take 8 digits from the side. 1 2 3 4 5 6 7 8. So after typecasting, the value will be 0 1, then 0 0 0 0 0 0, 6 times 0. So 8 digits will be there. So the value before 1 we can discard it, we don't need it. So now this value is, what is this value? So if I convert this value, so this will be 1 2 4 6, not 6, 8 16 32 64. I'm converting, how I'm converting it, each digit I'm converting. So this is 1, this is how we can convert. So the 8th bit is set, that means 64. That's why this program is printing 64. So that is how we solve it. If you need any clarification, or if you have any doubt, you can add your comment in the comment box. And if you like the video, please click on the like button and subscribe to the channel. And I will save this program again. And I have used just this single line comment here, C style comment. Even if I compile the program again, I will not get any error. And let me run it one more time. It should be 64. So yeah, this is 64. So that is what I wanted to explain in this video. And you can try running this on with a different type of data type, or a bigger value, a smaller value. But you have to know how to convert this integer values into binary format. So that's all I have. Thanks for watching.